Okay, so we're going to start our next unit today, and we're talking about exponents and exponential functions. Exponents and exponential functions. So today we're going to be focusing on multiplying monomials and adding and applying the power to power rule. Okay, so how do we multiply monomials and how do we apply the power to power rule with exponents? All right, so let's start with 2 to the 5th. What is the value of 2 to the 5th? What is the value of 2 to the 5th? How do I do it on my calculator? And what does it mean? So first of all, this is not 2 times 5. That is not what it is. This is 2 times 2 times 2, 5 times. 1, 2, 3, 4, 5 times. 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. So 2 to the 5th is actually 32. Okay, so let's learn how to do this on the Desmos calculator. Okay, so if I have 2 to the 5th, I am going to press 2, and then I am going to press this AB button, the A to the B, and see how it moves up in a power. Okay, and I'm going to put a 5 in there, and you'll see that my answer is 32. Okay, my answer is 32. So let's try another one. Let's do 4 to the 3rd power. So 4, A to the B, 3rd power, gives me 64. Okay, that is not 4 times 3. That is 4 times 4 times 4. So the first thing we need to know is how to handle those. All right, now let's remember what the pieces of a monomial are. So monomial is the single term. Okay, it can have powers, it can be multiplied, but it's a single term. So the big number or the big item is called the base. Okay, the big item is called the base, and then the small number is called the exponent, and this is sometimes called the power. Okay, sometimes called the power. So exponent and power are the same thing. All right, so let's use our calculator to try to figure out what these numbers are. So 4 to the 6th. So I'm going to go ahead and press 4 to the 6th power. That gives me 4096, 4096. I already did 4 to the 3rd. That's 64. And 4 to the 1st, well, that just tells me that's 4. Okay? Remember, this was 4 times 4 times 4. And this one is 6 times 2, 3, 4, 5, and 6. Okay? 6 times. Okay, now let's take a look at this. So this says I have a squared and I have a cubed. So a squared means I have 2a. So there's 2 a's right there. And then a to the 3rd means I have 3 a's. So how many a's do I really have? 1, 2, 3, 4, 5. So this is really a to the 5th because each of these has a power of 1. Well, so what did I do with the 2 and the 3? I actually just added them. Okay, I added them. So if this base is the same and I am multiplying, I can add my powers. Okay, this is called the product of powers. The product of powers. Okay, so base is the same. So let's think about what we have. We have 2 3's, and then we have 7 3's. 1, 2, 3, 4, 5, 6, 7. So 2, 1, 2, 3, 4, 5, 6, 7. So how many 3's do I have altogether? Yeah, it's 9. So I really took 2 plus 7 and I added and I got a 9. Well, what about this one? If that rule holds, then that means that's a power of 1 because if I just have a single base, it always has at least a power of 1. So if I'm going to add these, 1 plus 9, the base stays the same. 1 plus 9 is 10. Okay, 1 plus 9 is 10. And often when we are doing something like this, we leave this in exponential form, so we're not going to always evaluate, okay? We're not always going to evaluate. 3 to the 9th power is a big number. 5 to the 10th power is a really big number. So we don't always evaluate. Okay, so negative 7 to the power of 2, and this one is a power of 1. So that would give me negative 7 to the 3rd power. 2 plus 1 is 3. Okay, what about this next one? How many x's do I have? I have 2, I have 6, and there's a 1. So what is 2 plus 6 plus 1? 2 plus 6 is 8, plus 1 gives me a 9. So that is x to the 9th. Okay, so our rule is when we are multiplying our powers, let's make sure you see that this is a rule. Okay, this is called the product rule. When I multiply the powers, I get to add my exponents, but the bases have to be the same. Okay, the bases have to be the same. So x squared times x to the 4th is going to give me 2 plus 4 is 6. Y to the 10th times y to the 16th is going to be 10 plus 16, which is 26. All right, let's keep going. Let's take a look at these problems. So now I see I have numbers and I have variables. Okay, so I need to think about this in two pieces. The numbers, they're multiplying. Just multiply them. So what's 6 times 2? That's 12. Okay, so 6 times 2 is 12. Now with my variables, I know that I am adding like powers. So 3 plus 7 is 10. So that is 12 n to the 10th power. 12 n to the 10th power. Let's go to this next one. Multiply the numbers. Well, there happens to be a 1 right here. So 3 times 1 is going to give me a coefficient of 3. Okay, a coefficient of 3. Then I have to look for like terms. So I see I have a p, and the p has a power of 1 and a power of 3. Well, 1 plus 3 is 4. What about my t's? I have a 3 and I have a 4. 3 plus 4 is 7. So that is 3p4t7. Okay, why don't you hit pause, see if you can do the last two problems. Okay, let's see how you did. 7 times 3 is 21. 4 plus 5 is 9, so 21 y to the 9th. Negative 4 times negative 6, that's a positive 24. Negative times negative. Okay, my r's, remember that's a 1. 1 and 5, that's going to give me a 6. How about my x's? 2 and 2 is 4. And a 3 and a 1, that's going to give me t to the 4th. Okay, now let's look at our next rule. This one's called power to power. And this one kind of looks like distribution. Because if I gave you something that looks like this, 4 with a 2x, you would multiply 4 times 2, and that would give me 8x, right? So this time, I have parentheses, and I have something that looks similar to distribution. So let's see what we're saying here. So this says I have 3a squared. So here's a squared, a squared, a squared. There's 3 of them. But I know that a squared is 2a's. So I have broken all those out. How many a's do I have total? Yeah, I have 6. So how did I really get 6? What did I do with the 2 and the 3? I multiplied them. This is really a distribution. Okay, it is really a distributive property. So I am going to multiply when I have the parentheses, and it's raised to a power. So this is going to be x. 2 times 5 is 10. Y, multiply. 4 times 3 is 12. Let's keep going. 4, 2 times 7 is 14. What about this next one? Well, my base is negative 2. That is not going to change. 4 times 5, that's 20. That's 20. Okay, see if you can hit pause and get the last two. Okay, let's see how you did. We have n. 3 times 6 is 18. And the last one, remember, the base does not change. Okay, so whatever is inside the parenthesis the base, if you will, is not going to change. So the m plus 1 is the same. 5 times 4 is 20. Okay, so our rule is when we have a power, a monomial, like x to the fourth, and we're going to raise it to a power, okay? Raise it to a power. Let me write that a little bit better so it looks like, so x to the fourth raised to the second power. Anytime I see a power on the outside of the parenthesis, okay, on the outside of the parenthesis, that tells me that I'm really looking at a type of distribution. So I am going to multiply my powers, okay? So x to the fourth, the second power like we have there, gives me x. 4 times 2 is 8. If I have y to the third to the 10th power, I am going to multiply 3 times 10. So that is y to the 30th. Okay, and it still holds the same if there's multiple variables. Okay, so let's take a look at what happens if there's multiple variables. So this has a, b, so there's 3 of those. Well, that means there's 3 a's and 3 b's. So I have a to the 3, a cubed, b cubed. So when we see a power of 3, that is called cubed. So what I really have here is powers of 1, and I am multiplying. Okay, so I have to distribute to everything on the inside. So x, 3 times 2 is 6. The y, 4 times 2 is 8. Okay, now let's take a look at something that has a coefficient. So this is a power of 1. Okay, so I actually have to distribute to the 2. So 2, 1 times 3 is 3. Then I'm going to do my a. 4 times 3 is 12. The b, 5 times 3 is 15. And the c, 6 times 3 is 18. Now, this is going to give me a number that I can actually evaluate. So if I take 2 to the third power, that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. My answer is 8, A12, B15, C18. Okay, so I need to actually evaluate what that 2 to the third is. If it's a smaller number, we're going to go ahead and evaluate. Okay, hit pause, see what you can do with these. Okay, let's see how you did. Again, there's a power of 1 here and a power of 1 here. So I need to multiply to here. So 4 squared, a, 4 times 2 is 8. 9 times 2 is 18, and 1 times 2 is 2. Now I need to evaluate. 4 squared, that's 4 times 4, not 4 times 2. That would be 16. A8, B18, C2. Okay, same thing here. Let's distribute. 2 to the third, y to the third, z to the sixth, because I'm multiplying. 2 to the third is actually 8. So 8, y3, z6. All right, now this next one has multiple distributions. So I can see that there's a distribution here, and then there's one on the outside. So I'm going to go ahead and do the 2 first. So 3, 2 times 2 is 4. X, 3 times 2 is 6, and 4 times 2 is 8. Okay, so now I still have my 3 on the outside. And notice that's a square bracket, but it's the same thing as a regular parenthesis. So now I'm going to distribute again. So I have 3 to the 12th, x to the 18th, and y to the 24th. Okay, so I want you to look at the 12, and I want you to look at the 3 and the 2 and the 2. So what did I really do with those numbers? What did I really do? Yeah, I just multiplied. 3 times 2 is actually 6. 6 times 2 is 12. 6 times 3 is 18, and 6 times 4 is 24. So all I did was multiply the powers on the outside and distribute to everything on the inside. So I don't even really have to do it twice. Okay, so the rule when we have multiple things is that it has to distribute to everybody. So again, for an example, 4 squared, x3, y2. If this is a third power, it has to go to everybody. So 4, 2 times 3 is 6, 3 times 3 is 9, and 2 times 3 is 6. And sometimes I have to evaluate. Okay, so if I take 4 to the 6th, so 4, my a to the b, 6, that is 4096. So the best answer for this would be 4096, x9, y6. Okay, fractions work the same way. Okay, fractions work the same way. What I am going to end up doing is I'm going to end up realizing and remembering that these all have powers of 1, and I'm distributing to both of them. So a power of 1 and a power of 1. So 4, 1 times 2 is 2, and 1 times 2 is 2 again. So I have 4 squared over 3 squared. Well, 4 squared is 4 times 4, which is 16. 3 squared is 3 times 3, which is 9. And there's my answer. Okay? Again, it's going to go top and bottom. 1 times 4 is 4. 10 to the, so 1 times 4 there is 4. And we can go ahead and evaluate that. It's going to be some pretty big numbers, but we can still do it. 7 to the 4th is 2401. And 10 to the 4th is 10,000. So there is that answer. Okay, so same thing happens if I have 2 numbers on the outside. I am going to multiply these first. So 3 times 4 is 12. So what I'm really doing is taking this to the 12th power, which is 4 to the 12th and 9 to the 12th. And I'm not going to evaluate that because that is something very big. Okay, again, multiply these. 2 times 10 is 20. So I have 1/5 to the 20th power, which is 1 to the 20th over 5 to the 20th. Now, I can evaluate that top number because 1 to the 20th, that's just 1. So 1 over 5 to the 20th would be the best answer for that one. Okay, we are done for today. Go ahead and make some progress on your homework. And we're going to move on to 2 other rules tomorrow, actually 3, division, negatives, and zeros.